Hi students, welcome back. This is now the Chapter 5, Lecture 3, Part 3, the final section or final lecture over 5-3 of your of Chapter 5. Okay, I know I've been rather confusing on that, but anyway, this is the final one before we actually take the test. Okay, up and coming. Again, I want to remind you, if you could please obtain this document, it will help you be able to understand what is going on. Also, the document that I handed out dealing with the periodic trends in both a period and a group would also be helpful for you to have, as well as your online textbook to be able to refer to the figures and the drawings that will be mentioned within these notes. Okay, let's begin. It actually begins on E, and it's titled Valence Electrons, and asks you to take a look at Table 5-4 of your online textbook. Number 1, chemical compounds formed by electrons that are lost, gained, or shared between atoms. Number 2, a very important definition. Valence electrons are the electrons available to be lost, gained, or shared in formation of chemical compounds. Number 3, group 1 and 2 have 1 and 2 valence electrons. Groups 13 through 18 have the group number of electrons minus 10 valence electrons. Number 4, p block elements have both s and p electrons as their valence electrons. Under F, electronegativity, figure 5-20. Number 1, valence electrons hold atoms together in compounds. Number 2, Linus Pauling, Pauling, proposed electronegativity, which we abbreviate capital E, capital N. This is the measure of the ability of an atom in chemical compounds to attract electrons. Fluorine is the most electronegative element with the value of 4, and the other elements are calculated in relation to that. Number 3, period trends, figure 5-21 out of your online textbook. Under A, the electronegative tend to increase across each period, although there are exceptions. Under B, alkali and alkaline earth metals are the least electronegative elements. Nitrogen, oxygen, and the halogens are the most electronegative elements that attract electrons strongly in compounds. Under C, electronegative trend, and once again, I'm sorry, I can't read through the bifocals, they tend to either decrease down a group or remain the same. Under D, noble gases do not form compounds and are not assigned electronegative numbers. Under E, the highest values are in the upper right of the table and the lowest values are in the lower left of the periodic table. Number 4, we will do sample problem 5-7 and then we will practice these when we get to class. Under G, periodic properties of the D and F block elements. Refer to figure 5-14 and 5-16 of your online textbook. Number 1, D block elements vary less and with less regularity than main group elements. S sublevel contains 0 to 2, the highest sublevel electrons. Number 2, the atomic radii. Under A, generally they decrease across the period less due to shield of the N-1 DE electrons. Under D, the F block increase due to the increase in the atomic number from La to HF. Number 3, ionization energy. Under A, ionization energy of the D and F block increase across the period and increase down each group. Number 4, ion formation and ionic radii. Under A, electrons in the highest occupied sublevel are always removed first. The D and F block elements are exactly the reverse of order given by the electron configure notation. Under B, the D block elements commonly form +2 ions in compounds. C, iron and chromium commonly form +3 ions. Copper forms a +1 and +2 ions, and silver forms only a +1 ion. All of these cations have smaller radii than atoms as expected. Number 5, and finally, electronegativity. Under A, only group 1 and 2 D block elements have lower electronegativity. D block elements also follow general trend of electronegative values to increase as the radii decrease and vice versa. Under B, F block elements all have similar electronegativities. This concludes the final lecture of Chapter 5, Lecture 3, Part 3, or the final lecture of 5-3 section in your online textbook. I hope you've enjoyed it, and I hope I didn't put you too much to sleep, or maybe I am a very, very good sleeping pill. Regardless, we will continue to do some problem solving when we get to class and try to explain these terms in the sense of problems. And then we hope to be able to work a little bit in some smaller groups with you on the next time that we meet in class. Anyway, I'll see you then.